Hello, everyone. So this is another question. In this case, we are gonna work on a problem that will be complementary. Okay, so complementary counting. So the way we have a question says there are 25 chips. Okay, and each marked with a different integer 1 through 25, and that is actually placed in a jar. Okay, and it says takes one of those like chips and look at the numbers and write it somewhere and return the like number, I mean the chips into the jar, okay? And then 9 cents are gonna do the same thing, which is total of 10 of these, okay? And then what is the problem that at least two of those students, okay, will get the same number, okay? And then we are gonna look for a decimal near to the 100, okay? So like when you read the question, it's kind of too complicated because it's not really easy to see how can we deal with the at least all those will be the same number. Like it could be two of them same, could be three, could be four, could be five of them. Maybe all 10 will be the same number. But there are too many cases. When it is really challenging to do the case work, then it's maybe easier to do something else. Okay. If you like to find the something that is really harder to count, then just do something else to count what you don't really look for, okay? Which is actually has a name, which is we call complementary counting, okay? So let me complementary counting. So complementary counting is basically you do count what you do not want and subtract from the total cases, okay? So in this case, we do have 25 numbers, and we like to get at least two of those numbers to be the same, right? That's what we want. But instead of finding at least two of those numbers the same, we are gonna find how many ways can I actually do all those numbers are different, and I can subtract from the total case to find my actually probability, okay? So first law one, doesn't really matter. Let's say if you choose one of those 25, so regardless of what you choose, there's no concern, okay? Just that will be 1 out of 25 probability. And for the second one, since you want to get a number that will be different from the first one, and I do have 25 in total, and if I don't want to get the same thing that I received in my first one, I do have 24 choices left out of 25, because I'm just putting those back into the jar. So that will be 24 different like chips from the one that I took in the first selection. And then for the third selection, I do already know I picked one, I picked two, so which means I already have two numbers, even though I don't know what two numbers I do know, I do select, but I do know two of them already selected, so I cannot have the same number again. So now you do have 23 other options out of 25, and that will be for the third chip. And if you keep doing the same process, you will get 24 out of 25, I mean 22. Okay, so that would be 22 out of 25 and 21, 25, 20 out of 25 and 19 out of 25, 18, 25. So this is the first, second, third, fourth, fifth, sixth, seventh, eighth. So I should get 17 and 16 out of 25, okay? So this is the probability of getting no balls are same, okay? So this is not what we want, okay? But at the same time, you can just go ahead and multiply this one. Since this is a question on the target run, actually this is the last question on the target run, which meant to be challenging. And you can just go ahead and use a calculator, multiply these and just divide by those that many 25s. If you do so, you are approximately getting actually like 0.1244, I guess. Okay. So this is the probability of getting to all those numbers are different, okay? But this is not what we want. What we want is at least two of them will be same. So the probability of the total case is always 100%. So 100% is like 100 over 100, right? Which is gonna be 1. So the total case in all events are just 1, okay? So this is the probability of getting all those 10 numbers different. So what we want is gonna be actually their difference, okay? So let me write that. So at least probability of like getting at least two same, so the same number is actually 1 minus this number, so 0.1244. So if you do this, I guess we will get 0.87. And I'd like to, we are looking for the nearest 100, so maybe I need to write a few more digits just to make sure I'm not getting something wrong. So this is approximately my answer, right? But at the same time, we just need to make sure we are answering the question in the way that they ask. It says a decimal to the nearest 100. So I need two decimal digit, 2 digit after the decimal point. So it's 87, but after 7, we have 5. So when you have 5 or higher, so you are around this number up, right? So that should be 0.88. So you can write 0.88 or you can write 0.88. So either one is okay. And that is my answer. Okay, so I hope that makes sense. So one more key reminder, since as I said, this is a target problem. And if you don't like to multiply these, and if your calculator has a factorial like button, so you can actually do this quite a bit easily with your calculator with that factorial button. So you see, you are multiplying 24, 23 all the way to the 16. And like that's basically, you could just do 24 factorial, which means all the first 24 numbers multiplied, divided by, since we are going to multiply all these numbers other than first 15, I need to divide this by 15 factorial. So this fraction is actually going to be my numerator, okay? And then if I divide this guy by, since we had 25 of those, 10 of those 25, so you can just write 25 to the 10th power. Again, you can just use this instead of multiplying those like one by one. So you can use this one with your calculator if you do have a factorial in your calculator, okay? But that's the answer, and it's a really nice complementary counting problem, okay? So I'll see you next time.